All right, so at this point, we've got the ability to switch between our two main animations. And what I want to do now is show you how to update this animation system. So this is essentially the same one that was already included in the Paper 2D template. And it's good, but it's really good if you just have two different animations, and I want to add a third. Now technically, I've already added a third. I did this off camera, but you've already kind of seen the way that you go about this, so I'll just walk you through it. I brought in a character jumping texture that was included with all of the textures that we downloaded early on, and I created a sprite from this. So it's just called Jump 1. It is a single frame. It could be fancier, but really this is just a very simple texture that I hacked together in Photoshop from the running animation, just to show that we could bring in something different. Now, I did set the pixels per unit to 1.28 for that, so that he's the same size as all of the other sprites. And I also made a flip book for it, so that's also kind of important to keep in mind. We have a third flip book that is really just a single frame. So again, I realize it's a little cheesy, it's not exactly perfect, but it does allow us to see how to bring in a third animation. If you wanted to do something a little fancier on your own and have like an animation where the character's falling and pinwheeling his arms, you could do that on your own. So for now, let's go ahead and close this out. We've already seen how to make a texture into a sprite, into a flipbook, and let's go into our blueprint. What we're going to be doing is basically swapping out this simple Boolean select into something a bit more like a custom state machine. Now, getting the velocity and all that is important, but there's some other things that we need access to as well. We need to know if the character is going to be falling. And we get access to that from the character movement component. So if I come over here to my blueprint panel and we click Show Inherited Variables, we can see the movement component. So there's character movement. If I drag this in and get a getter and drag a wire off this, I can type out is falling. And this just comes along with the nav movement component. So this will tell you whether or not the character is airborne or not. So between whether or not he's moving and whether or not he's falling, we should be able to figure out which of the three animations we want to play. But we're going to make a few critical changes here. First off, this little select node, I'm just going to delete. We're going to get rid of that altogether. Let me pull the update animation node back, and we'll disconnect that for now as well. The first thing I want to do is store some variables. Now, this is really just preference so that my network doesn't get messy in any way. So what we're going to do is take our little network here, which gets the velocity, gets the vector length, and then converts that speed to a Boolean. And we are going to just promote this up to a variable. So let's just right-click on the pin, say promote to variable, and we're going to call this isMoving. And we're going to set that right away. Next, we're going to also add a variable for isFalling. Now, you don't really have to create these variables. I'm doing it as a personal preference because I like having access to variables in case I ever need that data again and don't want to drag wires all over my network. So let's right-click on return value. We'll also click promote to variable, and this will be isFalling. And we'll store that as well. Now, we have our data, and we want to process that data. We could just do another select, but what I want to do instead, just to, I guess kind of for academic purposes, but also for nice clean extensibility later on if we started adding a lot more animations, is I want to create a function. So let's do this. Let's start off by creating a new function. I'll just click on the plus function button here in my blueprint panel, and we're going to call this animation state machine. And what this is going to do is take in a few pieces of data, such as whether or not we're moving and whether or not we're falling, and it will process that data, run some tests on it, and then output an appropriate animation flipbook. So we need to deal with the inputs and outputs first. What are we going to take in? We are going to take in a Boolean value for whether or not we're falling. So let's do isFalling. And we will add another one. So click on the new button again, and this one will be whether or not we're moving. So this will be isMoving. Then using this data, after we perform some tests, we are going to output not a Boolean actually, but a flipbook. So let's just search for flip, and you'll see paper flipbook, so we'll choose that. And we will call this output flipbook. Okay, so we're going to take in this data, and we're going to output a flipbook. The question is how we process is falling and is moving to make this happen. Now, there's several different ways we could go about solving this problem. The way I'm going to show you is a way that I feel comfortable will make it easy for you to extend this later if you had a lot more animations to cycle through. So what I'm going to do first is create a library of the different animations this character needs. So let's start off here. We will add a new variable, and its type will also be a flipbook. So paper flipbook. And we're going to call this idle flipbook. I'm also going to go ahead and put this in a category, which I don't always do, but you generally should. We'll put this in a new category called animations. So there under animations, we have idle flipbook. Let's make a new variable, and we will call this one run flipbook. And just as before, we're going to set its category to animations. That's now in the dropdowns. And we'll add another one, which we will call falling flipbook. And we will set its category also to animations. Now we need to compile, and then we need to go ahead and set the default values for these. So we'll select idle, and if we click the drop down here, there are all the flipbooks we have access to. So we can set idle to idle, set run to run, and falling we're actually going to set to jump. So we got a little bit of a naming discrepancy there. Let's go ahead and just rename this so there's a little bit more consistency there. So we'll rename the falling flipbook to the jump flipbook. But you know, on your end, if you're doing this for a more complex character, you may actually end up differentiating between jumping and falling. So definitely food for thought for later on. I'll leave that to you to keep those organized in the way that you see fit. So let's make sure jump flipbook also has its jump flipbook associated with it. And so now we have a library of the animations that our character needs access to. So now what I want to do is create a switching mechanism. I want to be able to have a nice drop down that we can use to select the state that we want our character to be in, whether he's going to be falling or running or just idling. Now to do that, I'm going to create an enumeration. And enumerations are an important part of building something that is stateful, even when you're programming. So we're going to slide this out of the way, and over here in the content browser, in my game folder, I'm going to make a new folder. So just right-click, choose new folder, and I'm going to call this folder data. And within, I'm going to right-click and create a new, go under blueprints and choose enumeration. So again, that's under blueprints, enumeration. And I'm going to call this animation state. And if we double click this, we get the enumeration editor, which I got to bring back on the screen. All it is a way for you to create an enumerated list. So we'll click on new, and our first enum will be idle. We'll click new again, and our next one will be moving or running. Let's call it running. And our next one will be jumping. Okay, so we'll save that, and we can go ahead and close. Now here's where it starts to get kind of cool. Back over in our function here inside of our blueprint, I can right-click. Actually, let's do it this way. Let's create a new variable just for the inside of this function. Now, up to this point, all of the variables that I have created have just been regular variables for the blueprint. What I'm going to do now is create a local variable. That's a variable that only exists within the scope of this function. Now, the reason I created my flipbooks outside of the function is that I may need access to those at a later time. I may need to get the frame rate for those from something else, or any other piece of data from those flipbooks I may need access to outside the function, so I'll leave those outside the function. But anything that I know is going to remain just a part of the function itself, I will create as a local variable. So I'm going to click on plus next to local variables, and we will call this animation state. And we're going to set its variable type we just use the search line, we can set it to animation state, and there's our enum right there that we just created. So we can click that and go ahead and compile. And I'm going to drag this in, like so. We'll get a getter. Now, earlier we used a select node. You saw how we used a select with a Boolean, use that to switch between some flipbooks. We're going to kind of do the same thing here, but I want to show you how this works. I'm going to right-click in space. Notice I'm not dragging a wire, and let's make a new select node. And there you go. Now watch what happens when I plug my animation state variable into the index. The select node automatically updates so that we have inputs for idle, running, and jumping, which is pretty cool when you think about it. So now we've got these variables that hold those flipbooks. So let's just take the idle flipbook and we'll connect that to idle, and suddenly everything updates. It now knows that these are going to be taking in flipbooks. So now we'll take the run flipbook and connect that to running, and we'll take the jump flipbook and connect that to jumping. Okay, so we now have a switching mechanism. We can take the output of this, and that will be the output for our function. What we need now is a way to properly set the value of this enum, and that'll be the next thing we do. Now, mostly as a personal preference, and for no other reason, I often like to convert any incoming data into local variables. It's very helpful, I find, if my function starts to get kind of rich and I want to start collapsing nodes. So I'm going to take falling, and we'll right-click and promote this to a variable. And I'm going to call this isFallingLocal. Actually, whoops, you notice it didn't actually create that in the local area, so let me delete that. Goodbye. Yeah, I do want to delete it, so that should go away. Thank you. Let's create that as a local variable. So I'll click the plus button down here. I thought I could just right-click and promote, but it doesn't really work that way. So let's do isFallingLocal down here. And this will just be a regular Boolean. Now I'm going to Alt-drag a copy of that in, and we will connect isFalling directly to that. So that's the first thing we're going to do. We're going to store a local copy of whether or not we're falling. Let's do the same thing for moving. So we'll click the plus button, and this will be isMovingLocal. And again, Alt-drag, connect up the execution pin, and connect isMoving to our new local version. Okay, so now we've stored that incoming data. The next thing I want to do is perform some tests on this so that we can use those to set our animation state enumeration. So the order in which we test these is going to be important. You have to think about priority of animation. If we are ever in the air, whether we're moving or not, then we want to be playing the jump animation. So jump is actually going to be the most important thing to test for. We're going to test that first. Then we will test to see if we're running, and if we are not running, and if we're not falling and we're not running, then we must be idling. So that's kind of the relationship we're going to set up. And it's pretty straightforward. It's just going to be a few branch nodes. So let's drag a wire off our execution pin, and we will do a branch. Now, the way we're going to do this is this will be our check to see if we are falling. So I'm just going to take isFallingLocal and connect that right to the condition. If we are falling, and let me give myself some room here, we'll just spread these out. So if isFallingLocal returns true, that means we are currently in the air. So what I want to do at that point is take animation state, and we'll drag it over here and get a setter for it this time. And we would want to set the animation state to jumping because he's in the air. So that works. Now, if that fails, then we want to perform another test instead. So from false, let's do another branch. And this time, we're going to check isMoving. So grab isMovingLocal and plug that in. Now, if this tests true, then we want to set our animation state instead to running. And if that fires off false, we don't really have anything left to test at that point. We know that we would be idling, so I'm just going to copy paste one more copy of our setter and set this to idle. So we test to see if we're jumping. If we're not jumping, we test to see if we're running, and if both of those are false, then we must be idling. Now, the last thing we need to do is plug all of this back into that return node. And for cleanliness sake, the way we're going to do that is I'm going to drag a wire off my execution pin, and we will do a reroute node. And we'll just plug everything into the reroute. And I'll run the reroute into my return node. Now, I realize for those of you who have been doing a little bit of Blueprint work that I'm going just a tad overboard on my variables here. You don't really have to have local versions of this data. But if you're wondering why I did that, in some cases, I may have some data that's coming in that I don't need to create a variable for. For instance, if I ever expand this into whether or not the character is crouching, if we take a look over here, is crouched. B is crouched is already a variable. So I don't really need to create a fresh one for that. I can just get that at any point that I want to. So I like having anything that's going to be made of like a node network get saved off into its own variable for easy access later. But once I get inside of a function, and I don't need to create a new function, let me go ahead and delete that. Once I actually get inside of a function, I prefer having local versions in case things start to need to get branched around or if I have to clean up my graph. So let's get this integrated into our event graph at this point. All we got to do is take our animation state machine function that we've created and drag it in. And let's just make sure it's connected by way of our execution wires. And we plug in the relevant data. So is moving, we can just plug into is moving. Is falling, we can plug straight into is falling. And the output flipbook can go straight into new flipbook. And if we really wanted to, we should be able to do a little reroute there. And that'll just keep that nice and neat so it gets away from that sprite. OK, so we should test this. So let's compile, and let's save, and let's play our game. And oh, looks like we're running. That's a good sign. And if we jump, he pulls his legs up and goes into his little jump. So we are switching through all of our different animation states, and thereby playing the appropriate flipbook. So that's perfect. That's exactly what we want. If we sit still, he starts idling. So that's great. Now the last thing I'm going to do, and this is really, I guess mostly just vanity. We're going to do a little bit of cleanup here. So let's jump back inside the animation state machine function. And let's put some comment blocks in. So let's grab this first area, and we'll hit a comment block, and I will call this collect data. And we're going to do a couple things here. Now, what I'm about to do is, again, kind of over the top, but it shows off a cool feature. And if your tests were more complicated, then this would be kind of useful. For instance, whether or not you set a state may be dependent on multiple factors. You may have to say, all right, set this animation if the character is moving, but if they're not crouched and they're not falling, in which case you have to have much more complicated tests than what we have here. When I do that sort of thing, I will take the entire testing area, I will select it, and I will collapse it into its own little node. So just right-click on a selection and choose Collapse Nodes, and I will call this Test for Jumping. And if you see the error, make sure you compile, and the error goes away in this case. And then we'll grab these nodes, and we will right-click, and let's collapse these as well, and we will call this Test for Running or Idle. There we go. And again, just do a quick compile, and that cleans all of that up. Then let's do a comment block here. So we'll just call test data. We'll line all these up. And these will be set animation state. And then here, we'll just do one more, and this will be select flipbook. So now, somebody who comes into this function for the first time gets a really clean walkthrough of all of the different behaviors. OK, so now that we've got that, let's compile and save. And out here in the event graph, we can just grab all of this area, do one more comment block, and let's call this animation handling. Okay, so one more test compile, and I think it's a good idea to do one last test. And it looks like he's running and jumping and doing everything he's supposed to do. So with that, we have now created our 2D game. That's really everything I wanted to show in this video series. So you could technically stop watching now. I think what we're going to do next, though, is I'm going to show you guys a neat trick for building a 2D lift. But I'll give you a warning, it's not necessarily locked into 2D. You could totally use this to create a 3D lift as well. It's just something I was playing with when I was roughing out the notes for this project, so I thought I'd go ahead and show one more thing. But if you feel ready to go ahead and start adding in your own animations now, then you're technically done. Thank you very much for watching, and I hope to catch you on the next videos. See ya.